Out there. The police. You know, if you don't wear your seatbelt, the police will pull you over. Don't get pulled over. Let's do a problem with momentum and seatbelts and impulse. Okay? Momentum is mass times velocity. That's it. Nothing more. When I have a mass and I'm accelerating that mass times the acceleration, that is a force. But if I'm not accelerating that mass, there's still something there. It's confusing what's there. What's there is simply momentum. Momentum is mass times velocity. That's it. Now, you're driving down the road and you run into a tree. God forbid, you're in the car, you run into a tree, you have your seatbelt on, you come to a stop, and the seatbelt kind of stretches a little bit. So you stop, and let's say your body's actually stopping, let's say half a second, 0.4 seconds, okay? So you're going down, Lana, she's in a car, and she's going 25 meters per second, and pretty fast, and she's 60 kilograms, small, not terribly small. I'm 100 kilograms. It's about 220 pounds, so she's half that. And she has a seatbelt on, and she stops in 0.4 seconds. My momentum is what? 60 kilograms times 25 meters per second, correct? And that's going to be 1,500 momentum units. What's a momentum unit? What does that mean? Like force was kilogram meters per second squared, or just newtons. Rebecca, what's a momentum unit? It's just, right here, it's just kilogram meter per second. That's it. Nothing special, nothing fancy, kilogram meter per second. Correct? Easy? Mm-hmm. All right. The change, the momentum, is going to equal the impulse, which is a product of force and time. And that impulse will equal the change in momentum. If I'm going down the road and I have a momentum of 1,500, I come to a stop, the change in momentum is 1,500. The change in momentum equals the product, force times time. Here's where force comes in. So I have 1,500 equals F times 0.4, correct? Yes?
Yes.
Solve for F, 3,750. She's not going to walk away perfectly healthy. She's going to have some aches and pains. I'm 1,000 newtons. So it's 3 times my weight was forced on her body. 3 times my weight. So that's a lot. Correct?
Yes.
That's a lot. Matter of fact, she's 60 kilograms, correct? So what's her weight?
130 pounds.
Her weight is 600 newtons, right? Right? So 6 times her weight. That's what she's going to feel. 6 times her weight. 6 times 600 is 3,600. So she's going to feel 3 G's. 1 G is your weight. What do you weigh?
About 140.
All right, 140 pounds, that's 1 G. 1 G. 2 G's would be 280. 3 G's would be 3 times that single.
40.
420. It's a lot of weight to be forced on your body. It's a lot of weight. I'm a big guy, 6'4", 220 pounds. But if I had 3 times my weight hit my body, that would hurt a lot. But she'll be okay. She'll be okay. A little sore, okay? Now, that's if she has a seatbelt on. And that's why seatbelts are the law. Otherwise, the police will come in and arrest you. Let's say she doesn't have her seatbelt on and she hits the windshield. She stops instantaneously. 0.001 second. 1,000th of a second she stops. Now it's going to be 1,500 equals F times 0.001. That's going to be 1,500,000. 1,500,000 newtons. That's a lot of weight. That's a lot of force. What is 1,500,000 divided by 600? 2,500 times her weight is hitting her. What do you think? Not good.
No.
The body is so flexible, it can deal with a lot. But I was an EMT, and there's a limit. There's a limit. People who don't wear seatbelts routinely end up hurt, period. And this is why. It's the impulse. It's the change in momentum divided by the time. Let's say I hit a brick wall, and it was 0.0001 second. That would be...
Do you want me to stop it?
I was just filming. I just had a big film. I just like did like 4 or 5 minutes.